Good day everyone. This video is about tangents of a circle and its properties. So let's start. In this lesson, we will find the lengths of a tangent segment and measures of the angles and arcs using the theorem of a tangent. First, let's discuss what is tangent to a circle. A line in a plane of the circle that intersects the circle at exactly one point is called tangent line. The point of the intersection is called the point of tangency. Now in this illustration, this is a circle and a line that lie on the same plane. Now, as you can see, they intersect at exactly one point. So this is what we call the point of tangency, and this is the tangent line. So that is a tangent of a circle. Now let's discuss what are some of the properties of this tangent line or tangent to a circle. Now let's discuss first what is the first theorem of this tutorial, the tangent line theorem. If a line is a tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So again, this is a circle that circle C that is tangent to line AP. Now if we will draw a radius from point C to the point of tangency, this line is perpendicular to this tangent. That's why CP is perpendicular to line AP. So now let's explore problems involving this theorem. So in this problem, line AP is tangent to circle C at point P. If CP is 11 centimeter, AP is 60 centimeter, how far is point A from point C? So using this illustration, we identify our given, and we have this as our the distance from C to A. So we are asked to find that. As you can see, since this is a perpendicular line, and if we connect C to A, so this forms a right triangle, for we have this leg and this is our hypotenuse. So we will use the Pythagorean formula to answer this. We will need to find the length of CA, so that we will going to square root both sides. So we'll give this will give us this formula. Now let's substitute 11 to CP and 60 to AP. Now let's try to evaluate this. Then 11 squared is 121, 60 squared is 360. Now we add them together, we have 73,721, the square root of 3,721, and that is 61. So we have the distance from point A to point C is 61 centimeter. Another example is this gear. So we will have the following given in this gear. So I will just read the questions to you. A belt is tightly around two gears as shown below. Find the distance between the centers of the gears. So we will draw a line from the center of both gears, and we will find the distance of it. Now to answer it, we need to remember uh, the the illustration tells us that the circles are aligned on the point of tangency of both circle at the top. So if we will draw a parallel line from the above, we will create this kind of line. So this line measures the same as the line on the above of the circle, or the line tangent above the circle. So that is 15.2. Now, since this one is the measurement of this one and this one should be equal, so this is 1.5 inches and 1.5 inches. The illustration is not on scale, that's why it is somehow smaller than this. Well, in reality, when in the illustration, it's somehow longer compared to this. But just assume that this drawing or figure is not on scale. So now we have two measurement of two sides of the right triangle. Now we need to find the hypotenuse of this right triangle, and that is the distance between 2 points. Again, we will just use the Pythagorean formula. So 3.9 squared plus 15.9 squared is equal to x squared. So we will get the square root of both sides. 3.9 squared is 15.21 and 15.2 squared is 231.04. Now if we add them together, we will have square root of 246.25. Now the square root of 246.25 is approximately 15.69. So that's how we get the answer for this one. Now let's go to the next theorem. The next theorem is the converse of the tangent line theorem. In a plane, if a line is perpendicular to the radius of a circle at the endpoint of the circle, then the line is a tangent circle. So in this one, if we have a line and we have a radius that is perpendicular to that line on a certain point on the circle, then this line is a tangent to circle C at point P. So in this figure, ES is 10, EP is 26, PS is 24. Now we are asked to show if PS is tangent to circle E. So again, let's just prove that the Pythagorean, we just need to prove that this is a right triangle. Once that we prove that this is a right triangle, then we could assume that this is perpendicular to this line. And if thus, then we conclude that this one is a tangent line. So how do we prove that? We use the Pythagorean formula. If two sides of the equations are equal to each other, then they are perpendicular. The line ES is perpendicular to line to segment ES is perpendicular to line SP. Then PS must be tangent to circle E. Another example, another theorem. If two tangent segments are drawn to a circle from external point, then the two tangent segments are congruent, meaning OT and OU are congruent to each other. If this is 5, then the measurement of this is 5 as well. Now, on the other hand, the angles between the tangent segments and line joining the external point to the center of the circle are congruent. So meaning angle TOC is equivalent to OUC. So these two angles are also congruent. So that is the tangent segment theorem. Now let's try to to answer questions involving this. Now in the figure, quadrilateral pair is a circumscribed quadrilateral. Point L, point O, point B, and point E are the points of tangency. Now let's put on all the given. FL is 3 centimeter, AO is 24 centimeter, OI is 2 centimeter, RV is 2.5. Then let's find EF. Let's start with EF first. This is EF. So this is point of tangency, this is point of tangency, and they intersects on the external point. That tells us that these are congruent. So if this is 3, therefore EF is also 3 centimeter. Now FA, we have FA, the measurement of this and this. Now to find that, we need to find the measurement of this. And this one tells us that this is 24.4. So 22.4 I should say, because they are congruent, because these are two tangent lines that intersect at point A. So now 2.4 plus 3, that gives us 5.4. So the answer for FA is 5.4. So let me erase this first. So that's we have. Now RI. RI is the measurement of this angle, this segment. We know that this is 2.5. Now we need to find VI. Now VI is same as the measurement of this, because these are what the theorem tells us about. OI and VI are tangent in a circle and intersects at point I. So this must be 2. So that is the measure of that. Now 2 plus 2.5, that gives us 4.5 centimeter. Now we are asked to find the perimeter of here. Since we only lacking a measurement of this one, but this is 2.5. Because of this, they are congruent. So now we all have the measure of the unknown segments of the on the quadrilateral pair. Now all we need to do is to add them up, and that will give us 19.8 centimeter. So that's how we do to answer this question. Now another more problems on tangents of circle. Now there's another problem here. AB is tangent to circle C if it satisfies the Pythagorean theorem. So that's how we determine whether AB is a tangent to a circle. Since BC is the longest side of triangle CAB, assume that this side is the hypotenuse. Hence substitute the given lengths. So these are the lengths. Actually, these are the given. I just get it wrong when I do the PowerPoint. So if we substitute it, we can see that they are equal on both sides of the equation. So that's why this triangle is a right triangle and AB is tangent to circle C. So that is at point A. So that is the answer to this problem. Now we have a very unusual problem here. Now we don't know the distance, we don't know the radius of the circle. So, but we know that AB squared is the hypotenuse and BC is one leg and AC, no, AB is the radius or one leg of the right triangle if it is, and BC is the other leg which is 24, and AC is incomplete. We only know the measurement from the circle to point C, but we don't know the measure from the center of the circle. So that gives us the equation of R plus 16. So we have now this. Now let's do FOIL, let's square all of the things that we need to square. So R squared is plus 576 is equal to the square root of this binomial. If we square that, you could do FOIL method on that, or you could search on how to multiply how to square a binomial. So there's a technique there. So let's subtract R squared on both sides. That gives us this equation. Now let's subtract 256 on both sides to single out R, and that gives us this equation. Now divide both sides by 32 and we get R is equal to 10. Now the radius of the circle is 10 units. This one, CB is 5x minus 2 and CD is 8x minus 17. Now we are asked to find the value of x. So we know that these two are equal. So we just equate them to each other. Subtract 8x on both sides and add 2 on both sides. So that's we have negative 3x is equal to negative 15. Divide both sides by negative 3 and we know that x is equal to 5. So that's all for this tutorial. I hope it could help you in studying tangents to a circle. See you on our next tutorial. Bye-bye.